Week 7. How long do stars exist for? This is our Sun. It is an average sort of star. Stars do not last forever. They are made when massive clouds of gas collapse inwards due to gravity. Most of the gas is hydrogen, but there will also be small amounts of helium and other elements. These clouds are called nebulae. They are not clouds like those on Earth. Firstly, the atoms or molecules are very, very, very spread out. Secondly, the clouds are much, much bigger than the whole of the solar system. As the cloud collapses, the atoms move faster and faster until they have so much energy, the hydrogen atoms smash together, and each pair of hydrogen atoms makes a new atom of helium. A lot of energy is given out when this happens. This process is called nuclear fusion, and it is where all of the energy from our own Sun comes from. As stars are made in this way, they usually form in groups or clusters. Younger stars can still be seen in our night sky in clusters. As time passes, these clusters tend to spread. The cluster above is known as the Pleiades or Seven Sisters. All of these stars are younger than 100 million years. Our Sun is much older. It is about 4.6 billion years old. That is 4,600 million years old, or 46 times older than the stars in the Pleiades. You may have noticed when you look in the night sky that some stars look very white and others look slightly red. This is very noticeable in the pattern or constellation of stars known as Orion, shown above. The star in the top left is called Betelgeuse. It is bright and has a slightly reddish colour. The star in the bottom left is called Rigel. It is bright and very white. These differences in colour are to do with the temperature of the star. Rigel is a star that is much bigger than the Sun. It is also much hotter, much younger, and will come to an end much sooner. It is a type of star known as a blue supergiant. It might seem strange, but big stars do not last as long as smaller stars. This is because they use up their hydrogen more quickly. They are much hotter. Rigel has already used up most of its hydrogen, and fusion is happening using other elements. This can't keep happening because in the end the fusion of more complex elements stops giving out energy. If the star is big enough at this stage, it will explode. This happens because the energy being given out cannot support the weight pulling inwards. This explosion is what is known as a supernova. The remains of the star may then either form a neutron star or a black hole. Betelgeuse was once like Rigel. It is very close to the point when it will explode. Our Sun will never get to this point, as it is thousands of times smaller. As our Sun uses up all of its hydrogen, it will get bigger and bigger, until it forms a type of star known as a red giant. It will then lose its outer layers and become a type of star known as a white dwarf. It will be surrounded by what is left of its outer layers in what is known as a planetary nebula, similar to the one shown below. Once at this stage, it will cool very slowly over trillions of years and will end as what astronomers call a black dwarf. It is not thought that the universe is old enough for us to be able to find stars of this type. There is no need to worry about the end of our Sun. It will not happen for another 4 or 5 billion years. Our Sun is only in the middle of its life.